Okay, Assalamualaikum warahmatullahi wabarakatuh. So today we continue. We still in chapter 2, which is we will cover on 2.6. We try to finish it. This is the final subchapter for 2.6, chapter 2, which is 2.6, the latex concentrate factory. Okay, here is the process of latex concentrate factory. Mainly a large reception unit comprised of several tanks. I think I did mention this earlier. We go through this second times. They're capable of holding up to 2 days crops, and which act as a feed reservoir for centrifuge separator. And then a change of centrifuge separator, which are linked by pulley and a rail clean area where the bowl are dismantled, washed and disassembled. Then we have a bulking and storage unit for several more large tanks and provisions of concentrate dispatch either from drums or tanker. Previously I did mention about the bulking process to eliminate the slush and so on, so you need to allow the received latex to rest at least overnight before you can remove the slush via the bulking process. And then we have an auxiliary deammoniation tower for skim latex and coagulation facilities for the recovery of skim rubber. So during the latex concentrate process, you will produce what we call that skim latex, which eventually you will put in the ammoniation tower to coagulate it, so that you can remove rubber on the skim latex. Okay, before you can release the serums into what we call that bonding systems. Okay, and then the layout of factory is designed such as to optimize the use of the gravity of for the transfer of latex from one part of the factory to another. That's why if you go to that latex factory, you will see a huge tank, and usually it's very high because if we utilize the gravitational force to allow this free latex to flow to your production lineups, so that you can do that. We call that centrifugation and storage. For example, from feed tank to machine, from machine to receiving or storage tank, and from storage tank to drum or transportation tank. So dia menurun lah kiranya, so that from the higher level to the lower level, so that it can flow easily. Tips to maintain the quality of latex concentrate. I think this one is very important. Again and again I keep mention about this. Either might probably will be covered on test, or this is the standard procedure that you need to take into account when you go to industry. So please bear in mind, and more likely I would like students to memorize the tips on maintaining the quality of latex concentrate. The first one, keep a high standards of cleanliness of all collection vessels, collection tanks, storage tank and other utensils both in field and factory. So cleanliness is the most important, the first parts of latex concentrate processing, because this is the daily process that you conduct in latex factory, so that you need to keep your storage, your utensil, your equipment clean. Because if you are not clean your equipment or utensil, immediately it will start to grow microorganisms and effects on your latex quality. Ammoniates latex to required level without delay. The normal level is 0.3 to 0.6. Depends on the types of ammonia that you need to use. The concentration of ammonia, high ammonia usually up to 0.7, low ammonia usually at 0.3, depends on final product you want to produce. But the most important part is you need to add your ammonia, you need to preserve it immediately without delay, because although you can adjust the pH and the ammonia ammonia level later on. But the problem is with the VFA number. If you delay the process, the VFA number will be affected. Okay, and the latex should be stable, free from pre-coagulation, so that usually you need to sieve the latex when you receive free latex or concentrated latex before you go to that tower or the storage tank, so that every time you receive or every process involved in latex, you need to sieve it. So you need to remove pre-coagulation latex or rubber. And then free latex should have VFA number between 0.01 to 0.03. So this is the most important parts of the ammonation that earlier I did mention about the requirements of additions of preservative immediately during you receive or during tapping process, because the VFA number will be affected here. So you need to measure it, so that if your VFA number too high, you need to discard it. Do not mix with other latex, because it will affect the VFA number too. Okay, should have sufficient capacity of storage, which is the bulking tanks, to facilitate overnight dislodge. So usually you will receive a huge amount of latex, so that you need to have a huge bulking tank, so that your latex have a sufficient enough time for bulking process, and then you can dislodge it early in the morning before you proceed with concentration process. Lattices with high level of VFA number should not be used for concentrate production. Again and again I did mention about this, so please be aware about the VFA number. So probably you can do a duplicate on VFA number measurement calculation, so that when you go to industry, make sure you do it at least twice or 3 times before you can confirm the VFA number. If the VFA number is consistent and you know it's good range in 0.01 to 0.03%, so you should be able to proceed with concentration process, or else you need to discard it. Bear in mind about the VFA number. Okay, the RC of free latex should not less than 25%. When you receive a free latex, it should be above 2.5%. Why? Because when you concentrate latex which is lower than 25%, less likely you can produce concentrated latex at least 60%. So this is the reason why you did not process the 25 and below latex. And other reason, because there is usually latex dry rubber contents of free latex should be around 30. Okay, 27 is quite low, 30 and above. But if you see at 25, there is something wrong with the latex. Either tappers already add some substance to increase the amounts of the latex they sell to you, or the latex actually low in quality. So more likely you need to do some more testing. If you confirm it is within the spec, but the RC is slightly low, you might want to mix with other higher contents of the RC latex, so that you can at least have 30% of the RC before you proceed with the concentration process. And then disinfectant of tank and pipelines with disinfectants such as formaldehyde either should be made compulsory soon after washing. So disinfectant is very important, not only cleaning, disinfectant to remove any tendencies of microbes grow during after the cleaning, so that you can avoid from latex VFA number increase significantly. The separator running time should be fixed, so that the RC of the concentrate is maintained at reasonable level at the ends of the run. Then latex concentrate is ammoniated to required level. So once you produce a latex concentrate, bear in mind you need to measure the ammonia level. And then if more likely after the concentration process, the ammonia level will be reduced significantly, so you need to add some more ammonia so that it will reach the required level. And the latex concentrate is subject to minimum handling and transfer after centrifugation, so that after centrifugation process, this is where the MST measurement takes place. If you do the MST test, it shows that the more motion that you apply to your latex will promote flocculums. So the small coagulums appears on the latex. So because of it is concentrated, you need to minimize handling unless you want to produce it. Okay, you want to produce a final product. Okay. Then we have 2.7, the modified latex concentrate. This is very famous chapter. I usually use it on test or final exam, and of course we have more than 6 types of latex concentrate, modified latex concentrate in industry, but mainly this is the 6 major latex concentrate, modified latex concentrate that being used, and some of modified latex concentrate in industry are derived from these 6, maybe the combination of 2 or 3, because certain specs is required, so more process or more properties is added to the latex so the higher quality can be achieved. Okay, there are several ways to modify a standard concentrate, each of which gives risks of the specialty latex. Each of these specialty lattices has certain characteristic properties which are suitable for specific applications. So bear in mind what is the importance of this modified latex concentrate towards the application. Usually we produce a modified latex concentrate because of the final application. So basically we will cover these 6. The first one is double centrifuge latex. We have pre-vulcanized latex, freeze-thaw stabilized latex, methyl methacrylate grafted latex, deproteinized natural rubber latex, and low viscosity latex. So we go through one by one. What is double centrifuge latex? Double centrifuge latex is prepared by centrifugation, diluting the concentrates of free latex, the RC, with ammonia, water, and recentrifugation. Okay, the product of non-rubber content, then a single centrifuge as reflect latex by the lower TSC, the RC value. If you can see here, usually free latex around 30% of TSC, 32% of TSC, whereas the RC is 30%. Okay, so the RC value percentage usually is 25. During the centrifugation to produce 60% of the RC, TSC value increased to 61%, whereas the DRC is 60%, and TSC DRC value is 1.5. But if you produce using a double centrifuge latex, okay, 30% and centrifuge to 60%. So basically, the double centrifuge latex is the process. You centrifuge, you produce concentrated latex using centrifugation process, and then you add ammonia and water again, and you recentrifuge it. So maksudnya 2 kali you guna untuk centrifuge. Centrifuge dapat latex pekat, awak tambah air dengan ammonia, dan awak guna balik centrifuge machine to produce a 60%. Itu cara dia, cairkan dan pekatkan balik. So the effect is significant because the TAC values drop significantly, which is 60 from 61.5 to 60.8, and the RC remain the same, which is 60, and TSC, the RC value reduced significantly from 1.5 to 0.8. So this is the main functions of the double centrifuge latex, and usually the double centrifuge latex used for surgical deep goods and usually required for specialized premium latex. So you need to produce using a double centrifuge latex, or else you might not want to do process using a double centrifuge latex because it time consuming, and it can be slightly expensive because the double process you need to proceed. it might not written here in your slide, so you need to jot it down. It is used for surgical deep goods. Okay, remember. So double centrifuge latex usually used for surgical deep goods and specialized premium latex. Next, we go to pre-vulcanized latex. Pre-vulcanized latex is prepared by heating natural rubber latex with vulcanizing ingredient. Okay, this latex must be suitably treated with stabilizers such as potassium hydroxide, potassium laurate, or potassium hydroxide potassium cianide, which is suitable formulation for the preparation of pre-vulcanized latex is as follows. So here you have weights of dry rubber, 60% of NR latex, sulfur, ZDC, ZNO, KOH, and potassium cyanides. Okay, you can refer this recommended table for your ingredient, vulcanizing ingredients or mixing for your latex. And then heating is carried out at 70 degrees Celsius for 1.5 to 2 hours. After pre-vulcanization, the latex is clarified by passing through a centrifugal separator. Okay, this classification stage remove unreact vulcanizing ingredient, thus minimizing post-vulcanization or storage. So this step is very important to remove the unreacted vulcanizing agent. So only reacted vulcanizing agent being used or remain in the latex, and consequently change in viscosity or NMST remain minimal. So although there is slight changes in MST and viscosity, however the change is very minimal. And then the pre-vulcanization may carry out in the ammoniated free latex or ammoniated latex concentrate, so either free latex or concentrated latex. So either way, but the important part is ammoniated. Okay, so you need to preserve it before you can produce it. Pre-vulcanized latex give a films a better clarify and used in manufacturing of deep and cast good. Okay, you need to memorize this one. So usually for pre-vulcanized latex, it been used for deep and cast good. Okay, because pre-vulcanized films produce a very better clarity, okay, of the final product. So it been used for deep and cast good. So the keyword is deep and cast good. So basically you heat up and you add vulcanizing agent. Next, okay, the third one is freeze-thaw stabilized latex. What is freeze-thaw stabilized latex? Okay, when normal latex is frozen, okay, the latex may become unstable. Okay, so thus on thawing it may become more viscous and its mechanical stability decrease. Okay, so basically in a climate country we have a lower temperature, so there is tendency your latex to you store latex and latex will be frozen during the storage process. So when you thaw it, okay, your latex become more viscous and mechanical stability decrease because of the high viscosity. In more severe and prolonged condition of freezing, the latex may gel. Okay, if it prolonged for too long, it will start to gel. So the viscosity increase greater, it start to gel. It's no more in a liquid but in a gel forms. Okay, freeze-thaw stabilized latex is prepared by adding 0.2% weight over weight on latex of sodium salicylate and 0.04 to 0.08% of lauric acid to a normal latex concentrate. So freeze-thaw stabilized latex usually been produced by addition of these two chemicals. This chemical imparts the stabilities to the latex, which on freezing and thawing retain its fluid states. Okay, so basically when you add this chemical, you improve the stability of latex. When you need to use your latex, you thaw it and it will retain your latex, convert it into a liquid form or the fluid states itself. Okay, Freeze-thaw stabilized latex also has minimal viscosity and MST changes after freezing and thawing cycle. So although you do it repetitively, freezing, freezing and thawing, it will slightly affects on viscosity and MST. However, the changes is very minimal and is acceptable for manufacturing. It has apparent advantage over normal latex concentrate when used in temperate country. So this is very important. So if you export your latex to temperate countries, which is country with having a fall season or very low temperature, so you need to use the freeze-thaw stabilized latex. Okay, you don't want during shipping, so your latex will start to freeze, and when they thaw it, latex will start to gel or increase in viscosity and stability, MST, mechanical stability. Okay, the fourth one is methacrylate grafted latex. So this is the grafted latex. Okay, when methacrylate is polymerized in natural rubber latex using a free radical catalyst, a substantial proportion of a polymethacrylate or PMMA form become chemically grafted to a polystyrene chain. Okay, two such commercially available graft polymer, which is the Hevia Plus Mg30 and Mg49, contain respectively 30 and 49% of weight of PMMA. So it's very easy to memorize, which is Mg is methacrylate grafted, 30 and 40 number after the Mg represent the content of MMA in a grafted latex. So that commonly we have 30 and 49%. In latex forms, both these lattices are used in the manufacturing of adhesively for bonding dissimilar surface, example PVC and R, and as reinforcing agent in certain latex application. These lattices also impart better resistance to swelling by solvent and better tear resistant in latex film. So mainly the methacrylate grafted latex being used as a adhesive for bonding two dissimilar surface. For example, PVC and R, okay, rubber and plastic material, okay, maybe rubber and metal surface, so that with grafted MMA on natural rubber, so it will give a better adhesion between two surface. That's not all, because it also impart better in swelling resistance, because we know that natural rubber not good in swelling resistance. However, the MMA improvise it, and it will provide a better tear strength in a latex film itself. So that's why it is better to use as adhesive. And then the fifth one, Deproteinized natural rubber latex. What is deproteinized natural rubber latex? Later on I will use DPNR. Okay, the DPNR usually produced by the treatment of free latex with specific proteolytic enzyme in the presence of specific surfactant stabilizer, followed by concentration by centrifugation. Okay, this is the production flow for the DPNR latex. For basically, you will receive the free latex. You need to add the surfactant. Here's the functions of the surfactant, the proteolytic enzyme, and then you produce a treated latex. So you need to bear in mind, if you need to produce a deproteinized latex, you need to add the surfactant before you treat the latex. Okay, and then you add water, you dilute it, the latex. Okay, after that you go to the centrifugation process to produce a DPNR latex. Okay, of course the byproduct is a serum and skim latex itself. So this is basically the process. You need to know, if you need to produce a DPNR, you need to add the surfactant, okay, before the centrifugation process. Okay, surfactant, diluting, and then centrifuge. Okay, I keep repeating this because it might be important. Okay, what is the function of deproteinized natural rubber latex actually? Okay, deproteinized natural rubber latex actually to remove a significant amount of protein in a natural rubber. Previously, in last semester or early of this semester, I did mention about the amounts of protein that contained in a natural rubber. So that usually this protein will cover the dry rubber particles. So why you the process of deproteinized natural rubber latex is the process of eliminating or to remove a significant amount of protein. Why we need deproteinized natural rubber latex? The application is here when some of the user might have allergy, okay, with the protein. Some of the user may cause rashes on their skins when they are prolonged contact with natural rubber latex. So by producing a DPNR, we can eliminate or we can reduce severe effects of rashes onto allergic skins of users. So usually deproteinized natural rubber latex are specifically made for users that is cannot tolerate or have allergies with protein, or else we can use conventional natural rubber products. And then finally we have low viscosity latex. This concentrate is prepared by freshly centrifuged latex concentrate by treating it with 0.15% weight over weight on the RC of hydroxylamine natural sulfate. The addition of this chemical will stabilize the viscosity of rubber in the latex. Okay, usually for low viscosity latex we produce because we want to produce a very thin deep product or cast good. So we add the hydroxylamine natural sulfate to reduce the viscosity. So during the process dipping or the casting, we can have a very thin films or even distributions of the rubber on the what we call the periton itself. Okay, I think that's all for this chapter. I hope you can cover you will take your time to cover from chapter 2.1, subchapter 2.1 until 2.7, because after this we might probably have a first test that will cover chapter 1 and chapter 2. By that, Assalamualaikum warahmatullahi wabarakatuh, and very good. Goodbye.